Hello. In this video I've created a piecewise function, f of x, that is sitting there on the right. And what we're going to do is find the limit of this function as we approach 1. So what makes this particular problem unique is that as we approach where x is 1, so if I follow up here, we end up closing in on 2. So we have, for instance, right there, we have a y value of 0, y value of 1, here's a y value of 1.5, 1.75, 1.9, and so on, getting closer and closer to 2. But as we go toward 1 from the other way, as we head up there on that piece of the piecewise function, we're getting close to where, well, we're at 5 the whole time. Y value 5, y value 5, y value 5, y value 5. So our approach is toward a y value of 5. So what is the limit of f of x as x approaches 1? Well, this limit does not exist, specifically because they go to 2 different y values. But we're able to find the limit of this function if we look at it in 2 pieces. So the limit of f of x as my x approaches 1 from the left side. And so we have sort of like a superscript negative sign on that 1, and that notation indicates that as we approach from the left side. And that's what we did coming here. So we are on the left going toward 1, and we determined that as we came from that side, we approached a y value of 2. So the limit of f of x as x approaches 1 from the left is 2. And we can look at it again. The limit of f of x as x approaches 1 from the right this time. And what did we say we got there? Well, as we came from the right, well, we stayed at 5 the whole time, and as we got toward 1, we were never moving from there. So as we approach from the right side, and that's a superscript plus sign there if you couldn't tell, as we approach from the right side, our limit goes toward 5. So that's what limits from the 2 different sides do. If they don't go to the same number, our limit in general doesn't exist, but we can view these limits from their 2 different approaches. And that's all we're doing in this video. We are done.